Hello ladies, Mrs. Blaufuss here again. This is a supplementary lesson for coordinate properties of transformations, and it stems from the transformations that we talked about earlier, but we're working specifically on a coordinate plane now. So we have a few key vocab terms, some that we've already talked about. One is vector and one is translation vector, and we'll talk about both of these in the lesson. So in this lesson, our goal is to apply ordered pair rules to some basic translations, rotations, and reflections, and learn about vector notation. So how we actually write our vectors. So we're going to try a few examples. So first, we're going to use an ordered pair rule to describe how points can be transformed. And the first ordered pair rule we're going to use says that we're going to transform the polygon at the right using an ordered pair rule that xy becomes x plus h and y plus k. In this first example, we're going to use h as 2 and k as -3. So to transform the polygon at the right, we're going to use the ordered pair rule xy becomes x plus 2 and y minus 3. And we'll talk about the general rule in just a minute. So when we do this, we want to figure out what kind of transformation is this. Is it a rotation, is it a reflection, or is it translation? So let's use the coordinate plane to the right to actually apply this rule. So in this first one, our x is this point here. Our x is -2 and our y is 0. So we're going to use the rule x plus 2, and our x becomes 0 and our y becomes -3. And we'll call this point A. We'll just label our polygon so it's a little easier to read or to transform. So with point B, we're going to add 2 units to the x-axis, to the x-coordinate, and we're going to subtract 3 on the y-coordinate. For point C, again, we're going to add 2 units to the x-coordinate and subtract 3. And for point D, we're going to add 2 units to the x-coordinate and subtract 3 units to the y. So after we connect our points, we can see our transformed image. And looking at this image, if I were to imagine the vectors of each of these transformed points, I would notice that they are all parallel and they are all equal. They're all the same, exactly the same length. So this image is a translation. So the shape of the polygon is the same, the orientation is the same, the size is the same, but it's just shifted down 3 units and over to the right 2. So for a general rule for a translation, for any point on a figure, the ordered pair rule x, y becomes x plus h, y plus k. That results in a horizontal move of h units, so you're adding to the x-axis, that's horizontal, and a vertical move of k units, you're adding to the y-axis, that's vertical. So if xy is a point on the original figure, then x plus h, y plus k is the corresponding point on the image. So we can say an ordered pair can also be written as a vector, and that's vocab term. And then as you can see in this figure at the right, we look at the horizontal shift and we look at the vertical shift. A vector is named by its horizontal and vertical components. So the translation vector, which is another vocab term, for the example on the slide, the last slide that we just did, if we were to write this as a vector, we would write that it went over 2 units and down 3 units. So this is how we denote our vector in a coordinate plane. Now you try. Translate the quadrilateral by the vector -4, 2. Please pause while you work and unpause for the solution. So as you can see, you should have shifted the point S to the left 4 units because we're shifting our X coordinate. Since it's negative, we're shifting it to the left 4 units, just like a number line. To the left is negative, and then we're shifting it up 2 units because as we go up, our y coordinates increase. So P, you can see, becomes P prime, S becomes S prime, R becomes R prime, Q becomes Q prime. And each of these points is shifted to the left 4 units and up 2 units, and then the image points are connected to create the image of the quadrilateral S prime, R prime, Q prime, P prime. Now let's look at another type of transformation. So we're going to transform this polygon PQRS at the right using the ordered pair rule, where x, y becomes x negative y. So let's take a minute to do this transformation on the coordinate plane on the right. So point P, let's start with point P. We have -1, -2, that's the point. P is -1, -2. That becomes x negative y, so it becomes -1, +2. S is 0.31, and that becomes x negative y, so it becomes 3, -1. R is 0.7, -3, and that becomes 0.7, +3. And then Q is 2, -5, and that becomes 2, +5. So looking at our original figure and then our image, after we connect all of the points of our image to form our image figure, what type of transformation is this? So this rule says that every x coordinate stays the same and every y coordinate changes sign. So we applied that rule and we graphed our new image. But if we look at our image, if we go clockwise around our image, it's P, Q, P prime, Q prime, R prime, S prime. But if we go clockwise around our original figure, we have P, S, R, Q. So if you notice, the orientation has changed. So P prime, Q prime, R prime, S prime is not congruent to P, S, R, Q if you had been going clockwise. So this image, since the orientation has changed, we know it's a reflection because of these 3, rotation, translation, and reflection. Reflection is the only one that has a change in orientation. The size is the same, the shape is the same, but the orientation is different, so it's a reflection. Specifically, this is a reflection over the x-axis. So when we name reflections, we also want to name the line of reflection. And in this case, this x-axis right here is our line of reflection. That is the line where the points are being reflected over. Now you try. Use the ordered pair rule that we just practiced with. XY becomes X negative Y. And identify the line of reflection. So first, try this on your own and pause the video while you do so and unpause for the solution. So applying the rule, xy becomes x negative y. Point P stays the same, so P is the same as P prime. S becomes S prime, so point 1 negative 1 becomes point 1 1. Q becomes Q prime, so point 1 negative 3 becomes point 1 3. And R stays the same, so R is the same as R prime. So in this exercise, we were to identify the line of reflection, and that is the x-axis. Now let's try a third type of transformation. So we're going to transform the polygon at the right using the ordered pair rule. Xy becomes y negative x. So let's first apply this rule to the figure, and then we can identify what type of transformation this is. So first, let's look at point S. And point S is at 0, 0, and S prime is going to stay at 0, 0. Next, point P, which right now point P is at negative 5, negative 1. So P prime is going to be negative 1 because our y coordinate becomes the x coordinate, and the x coordinate becomes the opposite and the y coordinate. So negative 5 becomes 5 as the y coordinate. And then Q, we have Q at negative 1, negative 4. So Q prime becomes negative 4, 1. Applying the rule, xy becomes y negative x. And then lastly, R is 0.2, negative 2. So R prime becomes negative 2, negative 2. So now let's actually plot these points. So P prime is negative 1, 5. Q prime is negative 4, 1. R prime is negative 2, negative 2. And then we can label them and connect them to form the image. So when we connect our image points to form our image quadrilateral, we can see that R has moved from here to here. Q has moved from here to here. P has moved from here to here. And S has stayed the same. So our original quadrilateral PSRQ becomes P prime, S prime, R prime, Q prime. So the orientation is the same, the size is the same, but we can tell that it's not strictly a shift. We can see that it's upside down now. And we know it's not a reflection because the orientation is the same. And so we can say that this is a rotation. So how do we know this? Well, the orientation is the same, but there's not a vector that goes in the same direction. We didn't move every point over the same amount and every point up the same amount. And more specifically, we can say that this is a 90-degree rotation. So R, which was point 2, -2, has now become point -2, -2. So it shifted just from quadrant 4 to quadrant 3, or it rotated rather, from quadrant 4 to quadrant 3. Q has rotated from quadrant 3 to quadrant 2. P has rotated from quadrant 3 to quadrant 2. And S is the point of origin, and S becomes S prime is the same point, 0, 0. So using this ordered pair rule, a transformation using this ordered pair rule is a 90-degree rotation about the origin. So the origin is the center of rotation. Now you try. Transform the quadrilateral using the ordered pair rule that we just practiced with. XY becomes Y negative X. Please pause the video while you work and unpause for the solution. So by applying the ordered pair rule, XY becomes Y negative X. That again is a 90-degree rotation about the origin. So our P prime becomes 2, 2, S prime becomes 4, -1, R prime becomes 1, -5, and Q prime becomes -1, -2. So far we've learned 3 ordered pair rules. This first one is a transformation, where xy becomes x plus h and y plus k, where h is the horizontal shift and k is the vertical shift. The ordered pair rule xy becomes x negative y is a reflection transformation, and that's a reflection transformation across the y axis. And the third one, xy becomes y negative x, is a 90-degree clockwise rotation transformation about the origin. Now, these are not the only types of transformations that we can do. This is not the only type of translation or the only type of reflection or the only type of rotation. We can rotate something that does not have the origin as a center of rotation. We can have a line of reflection that is not the y-axis, and we can have a translation that goes down and to the left or up and to the right, or any combination of those. On your guided notes, you'll see a polygon in the same position for each of these 5 quadrants on your next page. We are going to do this together in class, so you do not need to complete this activity right now. And in our in-class activity, we'll come up with a few more conjectures using ordered pair rules. But what I do want you to answer is the summarized questions. So what do the rules that we talked about, the 3 rules for transformations that produce reflection? Actually, you know what? We'll talk about this in class. And actually, all 3 of these summarized questions we will talk about in class, because we need to do that activity before we talk about them. And same with the closing question. We'll talk about the closing question in class as well. So please jot down any questions that you have so far, and then come to class prepared with your completed notes. Thanks, ladies.